Good morning, everyone. Oh, hey, what's up? How y'all doing today? So, one of the challenges I had, which is the reason why I put that Make Hero short up yesterday, was this. I want to see if I get some stock that's the right cuts. I'm going to probably have to haul down a lot of material. If the Carvera Air can actually pull this off. So the length it can handle, I can tell you. The fourth axis, I don't know if it can handle this blade. I may do a different one, just because of how wide this blade is and how aggressive the pitch is. So I may end up doing a different style to use that fourth axis and to see if I can potentially get more thrust, change the kV of the motor, that kind of thing. But the idea behind this was to see if the Carvera Air or the Carvera, I know there's a couple different models, can actually cut this blade. So we would do one side, and then we would do a negative on another piece that this would fit into, and then flip the stock over and do the other side. I think it's doable. I'm not sure. I think it can be pulled off. With the Carvera Air, I'm kind of anxious to see if that can happen. So if I'm able to do that, that changes the game up significantly for me as far as creating the blades. Now, one of the things that we also want to be able to create is this center hub. So we want to see if this is going to fit on their bed plate. So I'm going to do some measurements on this. This also is one of those situations where you would have to do a double-sided cut for clearance here, which could be a separate tool path depending on how you jig this up on their table. But this part here also has an indent for the roller bearing, and it also has slots for 8mm screws. So, I'm sorry, 4mm. And then you have these sections here. Can it mill those with the right bit? And that's going to be the issue going forward. Does this have the capabilities? Does the Carvera Air have the capabilities to do this work? Is this work too big for their bed? I'm honestly curious. I'm going to do some measurements. I'm going to see if it can handle this. If it can handle this, it can handle the hub. If it can handle this and the hub and the blades, that means it can handle the main shaft. If it can handle all that, then all of my rotating parts that encounter force can be done out of aluminum, which is something I would really love to have happen. I don't have a problem flying the PETG, but to be perfectly honest with you, with the load that the fan has and the RPMs we're going to be spinning, this is going to be great for a maiden without a huge payload. But when we are using PETG blades, now they do have some strength, I'll give you that. But this is the main reason for this. That's what this is for. Can we create the necessary parts for this fan on the Carvera Air? So I'm hoping that they see this video. I hope they accept the challenge, and that I can actually try and mill this out. And it doesn't mean we're not going to fly this. This is obviously going to fly. So no worries there. This is definitely going to fly. We got blades ready here. PETG arrives tomorrow. A decent amount. I'll be able to start putting together the stator assemblies for this, for the next two fans that I have sitting over here. And hopefully the people at Makira can look at this and go, you know what? Challenge accepted. But right now I'm going to be doing some measurements. In the comments, I'll put the measurements down that I find. Can the hub be made there? Can the hub for the blades be made on it? Can the blade be made on it? Can the stator, bearing stator, be made on it? That's the main parts. The main shaft is thinner than the hub, so it's smaller than this. So it can, theoretically, this could be my baseline for what I need to have milled. So that's what we're going to go for. We're going to see if that can happen on the Carvera Air. So I'm going to run the numbers, and I will definitely put it in the comments to see if it's something that can be done with that machine. If not, we'll try to find a better machine, or one with a bigger build platform. I'm pretty sure that the Carvera Air is brilliant for what it's designed for. But we do have scale as limiting factors here. So crucial parts, bearing parts, motor mount parts, those kind of things, would love to be able to do them in aluminum. And that's what we want to try to accomplish. So let's see what happens. I'm going to do the measurements. I'll put it in the comments what parts fit. So this is going to be stator, hub, main blade, fan hub. Then, of course, the main shaft, you can't really see it too much because it's all inside here, but the main shaft is a little bit smaller than the diameter of the hub and goes all the way up to here. So we're gonna see if it's feasible, if it's something that can be done on their machine. Because I don't want to have to break this up into any more parts in order to CNC it on a smaller machine. So I'll be right back with you with those numbers. Look for them in the comments. Make sure you like and subscribe if you like what I'm doing. And we're going to keep going with the printing, keep going with the building, and eventually we're going to have ourselves a maiden. And I need a lot more carbon fiber rods, I'll tell you that. These are the structural rods that I'm using right here. These are the thick ones. These are thickens right here. So those are going to do the job. Definitely for the body structure. To reinforce all of these pieces as they connect together. As each nacelle connects. To make the whole drone. This table is going to have to be moved. Everything's going to be done on the floor, because there is no table in here big enough to hold the entire drone. So I'll be back with the numbers. Stator, hub, main blade, fan hub, drive shaft. Going to do measurements, see if the Carvera Air is even capable of handling the size. So stay tuned for that. Look in the comments. I'll have that information there. Make your own comments. If you got another machine idea, another manufacturer that you think would be a better overall CNC machine for desktop type CNCing, something that isn't too expensive but still has good precision, put it in the comments. I would love to hear about it. So yes, sorry this video is a vertical. I hope that doesn't bother anybody. But it's just the way I filmed it today. So, all right. I'll be right back with you with those numbers in the comments. Be sure and watch for them. And we're going to go from there. We're going to see which machine is going to be the best for me to make this thing work. Because, yes, we are going to do the maiden with this. I know people are going to ask. They're going to ask and they're going to say, are you going to do the maiden with the PETG? Yes, of course. But for a more rigid power system, I would love to have aluminum. And it'll mate up well with the PETG. And the rest of the outer parts can still be that lightweight material that we want with that printed material. Which eventually these can be used as molds, made carbon fiber, so on and so forth. I'm not going to get into all that. Right now we're going to get those numbers, get them in the comments, and I'm going to be checking the comments to see if you guys have any better CNC desktop solutions that aren't going to break the bank to get the parts milled that I mentioned. So we're going to be right back with you.